our rule for, in order for a limit to exist, I need my left limit to equal my right limit. So that'd be limit as I approach from the left must equal the limit as I approach from the right. In order for something to be continuous, first this has to be true. So left limit has to equal my right limit. And, oops, of f of x. And I have to be equal at that function value, f of c. For finding limits algebraically, first you need to plug in. If you get 0 over 0, that means indeterminate. That is not an answer. It means you cannot determine it. So you gotta mess with it. So that could be factoring, right? Literally factor, cancel out. If it's a radical, you're gonna need to multiply the top and the bottom by the conjugate. Conjugate is where you flip the plus or the minus sign. If it's complex fractions, so again, multiplying top and bottom, multiply top and bottom by that common denominator. Or sometimes you'll have to expand, and then things will cancel out, and once you've canceled everything out, they can cancel out, then you plug in again to get your limit. Intermediate value, first it must be continuous. And third, the value has to be between those two. And if you have proved it, then you proved it by IVT. As limits as x approaches infinity, these are just your horizontal asymptotes. For polynomials, we can use blah 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 to each CC. If you're looking at the highest exponent and it's bigger on bottom, that's 0. Bigger on top is infinity. And each CC's exponents are the same, then you're going to divide the coefficients. Careful with something like this, because this would become actually 3x over x, which is each CC, which is 3. And if I do it at infinity, right, that would be 3. If I do it at negative infinity, then this would be positive but over negative, so you would have to flip the sign. And if we're talking about exponents, e to the infinity is infinity, but e to the negative infinity is actually 0. So careful with infinity versus negative infinity for those functions. All right, cosine of 0, so this is 0, pi, 2 pi, pi over 2. Cosine here, that's like the x, that's 1. Cosine at pi, that's the x, that's negative 1. Cosine of pi over 2, x is 0 there. And cosine at 2 pi, that's the same as cosine of 0, 1. Sine of 0, sine is the y right here is 0. Y at pi is also 0. Y or sine at pi over 2 is positive 1. And then if we're back at 2 pi, the y is 0. What value of a is f of x continuous? Show your work using correct notation. So continuous, you need your limit as I approach from the left to be equal to the limit as I approach from the right, and also equal to the function value, but that's included in my left limit. So that's a of negative 1 plus 5 equal to a of negative 1 squared. Negative 1 squared is 1, so this is just a. Negative a plus 5, add the a over, that gives me 2a, so then a is equal to 5x. Here we've got temperature modeled by a continuous function. This is definitely an IVT, so I'm going to make sure I state h of t is continuous. Blah, blah, blah. Next I need to check 55 compared to the temperature at T2 and 5. So h of 2 is 60, h of 5 is 52. 55 is definitely between these two, so I'm going to write 55 is between the h of 5 and h of 2, because 52 is less and 60 is greater. So I have my two conditions. It's continuous. The thing I'm trying to prove is between the two I'm looking at. So because of this, so there is a time, blah, blah, blah. There is a time t on the interval 2 to 5 at which the temperature of the t is 55 degrees Celsius by IVT. So I have my continuous between the two values, what I've proven by the theorem and proved it by. Alright, we've got a graph. I'm finding the limit as I go to 4 from the left. So as I approach 4 from the left, well, either way, as I approach 4, it's 1. Which is the next question. As I approach from the left, it was 1. If I approach from the right, it's still 1. So then if they're both the same, then my limit exists. It's what I just found. Left and right are going to 1, then your limit is 1. Now continuity, so g of 4 is the function value. It looks like 2.5 to me. So because my limit, x approaches 4 g of x is equal to 1, and that does not equal the function value, then no, it is not continuous because of that reason. Alright, finding the following limit. So I have negative 2. If I plug in negative 2 here, that's going to be 0 over 0. I'm just going to know that. I'm not going to actually plug it in each time. Now, like on a test, right? Like if you were doing not a bunch of problems that were all indeterminate, you would plug in first. But I know that almost all of these that are plugging in values are 0 over 0, so I know I'm going to factor. So this is x plus 3, x plus 2. Difference of squares is x plus 2 and x minus 2. These cross off. And then now we're ready to substitute it. Negative 2 plus 3 over negative 2 minus, minus 2. That's negative 4 on top, positive 1, so negative 1/4. Here, 0 minus 0 is 0. 0 over 0 is indeterminate, so I'm going to have to factor. I'm going to pull out x squared. That gives me 6, not 6x, just 6, minus 5x squared. Pull out x squared here. I'm left with x minus 3. This crosses off. Now I can plug in x equals 0. So I have 6 minus 5 times 0 over 0 minus 3. These go away. 6 over negative 3 is negative 2. Here I'm going to substitute in, so e to the 2 times 0 plus sine of 0 over negative 2 e to the 0 minus cosine of 0. Sine of 0 is just 0. E to the 0 is 1. Negative 2 e to the 0, negative 2 times 1 is negative 2. Minus cosine of 0, so cosine of 0 is 1. We did this on the front, so this is just 1 over negative 3, or negative 1/3. Here, if I plug in b, I get b minus b, which is 0 over 0, indeterminate, so I'm going to factor x minus b, x plus b, over x minus b. This cancels, and now I'm substituting x going to b, so this will be b plus b, which is 2b. Here, this is limit as x goes to infinity, so this is like a horizontal asymptote. It's the Bobo Bodhi, blah blah blah, and eats blah blah blah. Here, this is bigger on bottom, so that's Bobo, 0. Another Bobo Bodhi eats cc. I have x cubed and x cubed, so this is eats cc. Exponents are the same, so I divide coefficients, which would be 5 over 2. Here, if I plug in 1, that's square root of 9. 3 minus 3 is 0. 1 minus 1 is 0, indeterminate. So I'm going to multiply top and bottom by the conjugate. Now the bottom, not much I can do with that. It's x minus 1 times what we just multiplied it by. But the top, I can multiply this. 3 times 3 is 9. 3 times this and 3 times the positive version will cancel out. So now I just have this times this. So that's going to be minus what's inside. When you are subtracting, all of that got subtracted. So this becomes, I'm going to do this off to the side, 9 minus 2x minus 7, which is minus 2x. 9 minus 7 is plus 2. So this is negative 2x plus 2. And then I'm going to factor out a negative 2 so that it's x minus 1. So this becomes negative 2, x minus 1, x minus 1, 3 plus square root of 2x plus 7. X minus 1 cancels out. I have negative 2 over this, and now we're ready to substitute it. X goes to 1. 3 plus square root. 2 times 1 is 2, plus 7 is 9, square root of 9. So this is negative 2 over 3 plus 3, which is 6, which is negative 1/3. Wait, a lot of math there. Here, this is another approaching infinity. So this is Bobo Bodhi eats cc. I need to know what my highest exponent is. So that would be the 3x times negative x. That would be negative 3x squared. And then x times x over x squared, eats cc, divide coefficients, that would be negative 3. Alright, here if I plug in 3, that would be, this was a typo. That's why I meant this to be 0. Okay. I'm going to pretend that was actually 0. And then what we would do, because if you plug in 3, you actually don't get 0 over 0, you get like a regular number. That was supposed to be 0. So what I'm going to do is I'm going to get rid of these denominators. So I'm going to multiply top and bottom by those common denominators. So then the bottom is just x times 3 times x plus 3. Top, when I multiply this times this, so 1 over x plus 3 times x plus 3. See how this crosses off and I'm just left with 3 in that first term? Minus. Now the next term I have 1/3 times the 3 times the x plus 3. This crosses off and I have minus x plus 3, but all of that got subtracted. So this will become 3 minus x minus 3. 3 minus 3 goes away, so I'm just left with negative x over x times 3 times x plus 3. Cross off the x, you're still left with a factor of 1 right there, so this is negative 1 over 3. Supposed to plug in 0. If you kept it, which of course you didn't know that that was supposed to be 0, you get 1 over 3 plus 3 is 6. 6 times 3 is 18, but it actually was meant to be 1 over negative 1 over 9. Again, if you had the 6, it's not a big, or if you had the 18, that was just a typo on my part. Alright, here, this is approaching infinity, so this is Bobo Bodhi, so I'm looking at my leading exponent, which is 3x. Square root of 4 is 2, square root of x squared is x. This would be like 3 halves. Now normally the negative infinity doesn't really matter, but because this one is getting squared and this one is not, this one would become positive, right? Square root it, that would be positive infinity, but this one I would just substitute in negative infinity, so I would have a factor of a negative right there. Here we've got another radical, so I'm going to multiply top and bottom by the conjugate. This becomes x plus 2, negative 3 times positive 3 is minus 9 over x minus 7 times what we just multiplied by. This becomes just x minus 7, right? 2 minus 9 is minus 7. Cross off, factor of 1, 1 over square root of 7 plus 2 is square root of 9 plus 3, square root of 9 is 3, 1 over 3 plus 3 is 1 over 6. Another Bobo Bodhi, so let's look at this. Square root of 16 is 4, square root of x to the 6 is x cubed. When you're doing a square root, that's the same as raising it to the 1/2 power, so you're halving the 6 power to 3. Over 4x cubed, and then this would just become 1. It's not going to negative infinity, you don't have to worry about signs then. Alright, here we are looking at approaching negative infinity, still Bobo Bodhi. Leading exponent, that's bigger on top, and then you'd be plugging in 4 negative infinity cubed, which is negative infinity. Another complex fraction, this one is definitely 0 over 0 when you're plugging in. I'm trying to get rid of these denominators right here, so I'm going to multiply 4 times x plus 2 on top and bottom. Top, you can't really do much with it, x minus 2 times 4 times x plus 2. Bottom, when I multiply 1/4 times this, the 4 cancels out, I get x plus 2. Minus, when I multiply this term, these cross off and left with 4. Simplify the bottom, plus 2 minus 4 is the same as just x minus 2. X minus 2 or x plus 2. X minus 2 crosses off, and now it's just 4 times x plus 2. So then when I plug in, it's 4 times, we're plugging in 2. 2 plus 2 is 4, which is 16. Here, this one is asking for the limit as I approach from the right side, so that's x greater than 2, which would just be 3 times 2 minus 1, 6 minus 1 is 5. If you plug into this one, you're finding less than 2, so less than is on the left side. And if you're like, they don't match, well, yeah, I completely agree they don't match. The limit does not exist, but the limit from the right still is 5. Which of the following does the limit not exist for? 1 from the left. So I can go to 1 from the left is just equal to 1. So that exists. Oh, sorry, that's not 1. That's going to, that was 0. If I go to 1 from the left, that's going to 0, but it still exists. The limit as I approach 1 in general exists because it's going to 0 on either side, so it's still 0. As I go to 3 from the left, so 3 is right here. If I come up from the left, this is equal to 2. If I go to 3, well, I'm going to 2 on one side and negative infinity on the other, so that does not exist because left and right are not equal. And the limit as x approaches 5, definitely going to whatever 4 point something value that is, so that exists. Limit of g of x, so I need to find the limit as x approaches 2 from the left, which left would be 2 squared, which is 4. The limit as x approaches 2 from the right, that's going to be 3 times 2 minus 2. 6 minus 2 is 4. So then my limit as x approaches 2 is just 4, because the left side equals the right side. Is it continuous? And now we need to know what g of 2 is. There's no equal to sign, so at x equals 2, I don't know what to use because it is undefined. It's not defined for when x equals 2. So no because g of 2 is undefined. Limit can still exist, but this is undefined because I don't have at x equals 2 defined. Alright, I want to make it continuous, so the limit as x approaches negative 2 of h of x, that would be this side right here. So I'm going to take my x squared minus 4, x minus 2, x plus 2 over x plus 2. That crosses off. This is just x minus 2, and we're plugging in negative 2, so negative 2 minus 2, which is negative 4. So this is my limit. If I want to make it continuous, then my function value, my h of negative 2, has to also be equal to negative 4. So at x equals negative 2, I need this value right here to be negative 4. So that's the value of c. Because then, only then, would my limit be equal to my function value. Then would my Twizzlers be meeting at the skittle right there. Alright, jump discontinuity is when it jumps, so that would be at x equals 2. Removable discontinuity is when I can fix it very quickly by putting a skittle, so that would be at 6. If I just put the skittle right here, it would be fixed, so that's at x equals 6. Does my limit exist? Is it continuous? Explain. So my limit is going to be everywhere except at 1. So the limit is this right here. So if I plug in x going to 1, that would be 1 plus 2, which is 3. What this means, again, if I were to sketch this graph, plus 2, this is my line. My equation is x plus 2 for everywhere except at x equals 1, so whole right here. And then what this is saying is at x equals 1, you have a function value of 4. So I just found that the limit is 3, function value of 4 at 1. So here, yeah, my limit still exists everywhere except for at the exact point I'm looking at, but on the approach is going to 3. If I'm asking is it continuous, no, because my function value is not equal to that limit. So no, because the limit as I go to 1 of g of x is 3, which is not equal to the function value at 1, which is 4. Alright, if the limit exists, circle anything that must be true. Not might be true, but has to be true. So if your limit is existing, right, the rule is that your left limit has to be the same as your right limit. So left and right are going to the same value. So limit as I approach from the left and right have to be equal. It does not have to be defined, right? Your function value, it could be a whole. You could still have a limit, right? It could have a skittle, right? It could be defined, or it could not be, so that's not necessarily true. The limit has to equal the function value. No, again, this right here is no function value, but it's still a limit existing. So not true, not necessarily true. It has to be undefined. No, not necessarily, because this one, the limit exists and it is defined, so that doesn't tell me. Has to be continuous. No, it could be, but it also could not be. See how you have a limit here, but it is not continuous, so that does not have to be true. The only thing, if your limit exists, is that it has to be left limit equal right limit. Now for continuity, left limit has to equal right limit and has to equal your function value. So yes, your limit has to exist 100% because, right, that's step 1 for continuity. So left equals right, limit exists. It has to be equal to your function value, so you have to have a function value that's defined, and the limit has to be equal to it. So all 4 of these must be true if it's continuous then. If f is undefined, then the limit does not exist. So no, for a super similar reason to up there, I could have something like this. This is undefined. I can absolutely still have the limit, because the limit is about the approach, not what's happening at this point. It's not continuous, but it definitely still has the limit. So the limit does not exist, that's false. You can still have the limit while it's undefined. Alright, horizontal asymptote. So this would be the limit as x approaches positive infinity and the limit as x approaches negative infinity. So as we go to positive infinity, this will become 5 plus 2 to the infinity over 1 minus 2 to the infinity. These are huge numbers, so plus 5 and 1 doesn't really count. So see how it would become 2 to the infinity over negative 2 to the infinity? That's Bobo Bodhi ECC. These are like the same coefficient of negative 1. Now as I approach negative infinity, 5 plus 2 to the negative infinity, 1 minus 2 to the negative infinity. If I raise 2 to the negative infinity, that's just 1 over 2 to the infinity. 1 over infinity is going to go to 0. So see how as x approaches negative infinity, this goes away. It's so tiny. So then you're just left with 5 over 1, which would be 5.